Hey everyone, and welcome to this explainer. We walk past HVAC systems every single day. We hear them humming away in our offices, our data centers, our warehouses, but very few people actually understand the beating mechanical heart inside of them. Well, today, we're going to fix that.
There is a saying in the industry, if you don't understand HVAC fans, you don't understand airflow. It's a bold statement, but honestly, it's the absolute truth of the mechanical world. The massive problem today is that most people judge a fan just by what it looks like on the surface, not by how it physically performs. And judging a fan by its appearance alone, that is exactly why systems get designed wrong, installed wrong, and why initial project estimates get completely botched. Not all fans are created equal, and choosing the wrong one will literally ruin your system's performance.
Okay, let's dive into this. Here is our structural breakdown, so we know exactly how we're going to master this fundamental knowledge. We'll hit the foundation of airflow, axial fans, centrifugal fans, plenum fans, and fan walls, a quick field identification guide, and wrap up with why fan selection matters.
Part 1, the foundation of airflow. Because getting this right is the bedrock for everything from basic rooftop units to massive warehouses.
Moving right into Part 2, axial fans and straight airflow. Let's look at how these specific fans direct the physical journey of the air.
When you think of axial fans, I want you to picture the actual physics of the movement. The golden rule here is that air moves in a straight line, parallel to the fan's shaft. Just picture a classic propeller, right? Pushing or pulling air directly straight through a duct or a housing. It's easily the most recognizable type of fan out there, but assuming they all perform the exact same way is a major rookie mistake.
Let's unpack how this works across the three main subtypes of axial fans. First up, you have your basic propeller fans. These are your simple, cost-effective workhorses used in very low-pressure stuff. Think of a basic wall exhaust fan. But the catch is, once you introduce ductwork or any kind of resistance, their performance just drops off a cliff. Next step up, we have tube axial fans. These handle slightly higher pressures and usually get installed directly into duct systems. And finally, the heavy hitter of the group, the vane axial fan. These use special guide vanes that actually straighten the airflow, allowing the fan to handle massive static pressures. If you've ever felt that aggressive wind blasting inside a subway tunnel, you've definitely met a vane axial at work. So while axial always means straight through airflow, the performance entirely depends on the specific design.
And this brilliantly illustrates the core binary difference in the fan world. On one side, we have our axial fans, giving us that straight-through airflow we just talked about. But centrifugal fans, they do something entirely different. They take that air, pull it into the center, and aggressively discharge it at a sharp 90-degree angle.
Which brings us to Part 3, centrifugal fans and that 90-degree airflow.
These guys are the heavy pushers of the industry. By forcing air to make that sharp 90-degree turn, they generate significantly higher static pressure. That makes them the absolute ideal choice for complex, ducted systems like the air handlers you see in most commercial buildings. But just like our straight shooters, blade design dictates everything. We start with forward curved fans. Lots of small blades creating high airflow at lower pressures. You'll usually spot these in smaller or older air handlers. Then we evolve to backward inclined fans. Notice the shift here. Fewer blades but much larger. This makes them way more efficient and capable of handling higher pressures. And finally, we reach the absolute pinnacle, the airfoil fan. It's a highly aerodynamic backward inclined fan. They are the most efficient option available, period. Reserved for high-performance stuff like huge air handlers and data centers.
All right, Part 4, plenum fans and fan walls. We're leaving the traditional housings behind for these modern marvels.
So, what exactly is a plenum fan? By definition, it's actually a centrifugal fan, but with one massive difference. It entirely lacks a traditional housing or scroll. Instead of being boxed in, it discharges air directly into an open plenum space. By ditching the housing, you completely eliminate the need for complicated duct transitions. This allows for incredibly flexible layouts in large, built-up air handling units.
Now, what's really interesting about this slide is the sheer scale we can achieve. 12. In modern applications, plenum fans rarely fly solo. They get arranged in grids, called fan arrays or fan walls, linking 6, 8, or even 12 of these smaller fans together into one massive, coordinated system.
Why on earth would you want a wall of 12 small fans instead of just one giant one? Well, 3 massive advantages. First up, redundancy. In a fan wall, if one single fan goes down, the rest simply pick up the slack. The system keeps running. Second, efficiency. The entire array intelligently ramps up and down based precisely on the building's demand. And third, maintenance. Let's be real, replacing a small, modular fan is vastly easier, safer, and cheaper than trying to hoist out a gigantic, incredibly heavy piece of machinery. This grid approach is exactly why fan walls are completely dominating mission-critical facilities where uptime is absolutely everything.
Part 5. Quick Field Identification Guide. Let's get you a mental cheat sheet for the job site.
So, the crucial point is rapid-fire recognition. Commit this to memory. If you see air moving straight through, axial fan. Air gets pulled in and turns 90 degrees, centrifugal fan. No housing at all and blasting into open space, plenum fan. And if you see multiple small fans arranged in a grid, fan wall. Understanding just this simple breakdown will immediately and dramatically improve how you read blueprints and instantly identify fans out in the wild.
Finally, Part 6. Why fan selection matters. Time to connect this all to the real world.
Because this isn't just academic, right? Choosing the wrong fan isn't just a minor hiccup, it completely ruins everything down the line. It destroys airflow delivery, ruins energy efficiency, and creates massive noise issues. Think about the ripple effect here. For estimators, the wrong fan means cost accuracy goes out the window. For project managers, it guarantees the system won't perform as promised. And for the field teams, it's an installation nightmare and an endless headache for troubleshooting. Getting this right is completely non-negotiable for system reliability.
Which leaves us with one final thought. Will you ever look at a fan the same way again? I certainly hope not. We really have to look past simple visual recognition and understand the real-world performance behind the equipment. In our next deep dive, we'll be zooming in close on axial fans, exploring exactly when to deploy a simple propeller versus a heavy-duty vane axial. Until then, keep looking deeper into the mechanics around you.